everyone, my name is Sumant. In this video we are going to discuss about applications of autocorrelation function. So the given objective is to compute the pulse rate from the PPG signal and the pitch period of a speech signal. So let us see about the autocorrelation. So autocorrelation is nothing but the comparison of itself in the delayed version. The formula is Rm equal to 1 by R of 0 sigma n running from 0 to capital N minus m minus 1 x of n into x of n plus 1 m, where m runs from 0 to n and capital N represents the number of samples. So the properties of autocorrelation are: it is an even function and R of 0 gives the energy of the signal. The autocorrelation function will be periodic when the given signal is also periodic, and it decreases monotonically. So in this graph you can observe that it is a autocorrelation of a signal, and here at the 0 value it is maximum, it decreases monotonically, and the same part repeats in the negative y-axis as it is an even function. So let us see the procedure what we need to do. So firstly, to find the pulse rate we need to compute autocorrelation. So before computing autocorrelation we need to first remove the noise. So we need to smooth out the signal by passing it through the MA filter, and we need to find the mean and subtract it from the signal so that it shifts and normalizes. So after that we can find the autocorrelation and follow the remaining steps to find the pulse rate. So let us see that. So this is the PPG signal sample, and here are some initialized elements, and in the loop firstly we ran the MA filter, and afterwards here it is asked to do in a frame duration of 5 seconds. So here the given signal consists of 2000 samples. So we knew that he has given that sampling frequency is 100 Hz. So it represents 1 second. 100 signals takes 1 second. So for 2000 signals it takes 20 seconds. So it means for 5 seconds we need 500 signals to take as one frame. So what's the advantage of this is the output, means the pulse rate we are obtaining does not get delayed, means we need not wait for the output and we can collect the data quickly. So for that what we have done is we have used another variable known as z, and we have run such that for every 500 samples the whole loop runs and it starts for the remaining 500 samples. So here we firstly passed it through the MA filter, and next we found out the mean for every 500 samples. We have subtracted it from the signal we obtained, and after that we have stored it in the first, and here we have found out the energy of the signal as we need it to normalize it in the autocorrelation function. And after that we found out the autocorrelation function of the signal. Next what we need to do is here we need to find the first zero crossing point and find the second maximum peak, so that we know that the first maximum value will be at 0, but we don't know the position of the second maximum value. So if we find the first zero crossing point, then we can easily find the second maximum, and the distance from the 0 point to the point at which the maximum value exists is the period. So if we find that value we can find the pulse rate. So for that initially we have found out the first zero crossing point, that is by we have took the autocorrelation function signal and we have declared it as greater than 0 and less than 0, so we get the zero crossing point, and we used C++ and we have given here c equal to 0 so that it comes out of the loop. And next we have found out the maximum value here, as the I value remains at the first zero crossing point, and with that we have found the Lmax, which is the distance from 0 point to the point at which the maximum value exists. And here we use z minus so that we get each value, each pulse means each pulse rate value for 500 samples frame. Here we use 6000 because we have 100 samples and we need for 60 seconds, as it is beats per minute, the pulse rate is beats per minute, so 60 into 100 gives 6000. So here we have done it two ways, with filter and without filter. And with filter case we have got 66.6, and without filter case 65.44, and the error we have calculated, we got 1.7%. So let us see the next part, the speech signal part. Here the sampling rate is 8000 Hz. So the whole procedure will be same, as we need to find the pitch period, which is the pulse rate here, but we need not to multiply the 60 seconds as we need it for only 1 second here. So let us see that part. See, here you can see that everything will be same, except we need here for 8000, as he has asked for 8000 samples, and when we divide it we get the Lmax. So everything is done same. So here, but what's the difference is, as he asked for the speech signal, I have recorded my own speech signal in Audacity software and have converted, and I have given here the samples. The output I have obtained is, the difference in error is nearly minus 1.45%. So this is the pitch frequency and this is the errors I have obtained. So this is the pitch period for the my speech signal. So these are the applications of autocorrelation. Thank you.